Okay, number 12. Well, I'm looking at these bases, and 28 and 10 have nothing to do with each other. You could choose log base 28, you could choose log base 10, or just log. Uh, that means at some point we're going to have to use a calculator. So in most cases, I'm going to choose ln, but because this is a 10, I'm going to choose base 10, and I'm going to use log both sides. So we're going to log both sides of the equation. And because the two bases are different, one's a 10 and one's a 28, that means we're going to have to do different things to both sides of the equation. So this is log base 10, this is 28, so nothing cancels out here. So in order to get this x out of the exponent, we're going to use the power rule. So that x is going to shoot right out in front by using the power rule. So we have x log 28 is equal to, now this is log is base 10, and that's a 10. So we don't have to use power rule. We could bring that out in front, and then log base 10 would just be 1, and we would be left with this. But this log and this 10, it's like they just cancel right out, and you have the minus 3x. Now at this point, we're going to do any distributing, because as soon as you use power rule for this, a lot of times we have distributing. After that, we're going to collect x's on one side, then we're going to factor and divide. Because I don't see any distributing anywhere, that means I have to collect everything with an x on one side. So this whole thing has an x, this whole thing has an x, so I'm going to bring both to one side. Because this is a negative, I'm going to add this to both sides of the equation. So we have x log 28 plus 3x is equal to 0. Okay, after you collect everything to one side, then you GCF out the variable you're looking for. So we're going to pull that x out front, and we have log of 28 plus 3 is equal to 0. And then I'm going to divide both sides by this. So this side just gives me x, and over here we have 0 divided by all of this. Okay, the good news, the top of this fraction is 0, so that means it's 0. Now, we do have to consider, can this ever be 0? Because that would be cause dividing by 0. Now, log of 28, 10 to what power is 28? Well, that's going to be a little bit more than 1. Now, the good news is that's going to be a positive number, and you can put this right in your calculator if you want. And log of 28 is going to be bigger than 1, and then 1 plus 3 is also bigger, is a positive number. So that means 0 divided by all of this junk is going to be 0 because the numerator is 0. And our answer is 0. And we're done. Okay. This one, 15 and 30. Even though 15 goes into 30, it doesn't go into it exponentially. It goes in using multiplication. So there's nothing nice about these numbers. And we could use log base 15 if we want. But again, we're probably going to have to put this in a calculator. So I'm just going to use natural log on both sides. Okay, because the natural log is base e and this 15 is not the same base, we have to use power rule. So we bring that out front. And there's really nothing to do to that side. Okay, after this we do any distributing. So I don't see any of that. Now we're going to collect. We collect all the stuff with x's on one side. That's all this. And we collect everything that's not x on this side. Well, that's already done. I only have x's on this side. And then we do any factoring. And we don't have that because I only have one term. And then we go ahead and divide. So I'm going to divide both sides by natural log of 15. And these cancel, leaving x is natural log of 30 over natural log of 15. Now, that's as exact of an answer as we can get. And then we can also put it in a calculator and get an approximate answer. Okay, and it looks like I have 1.256. Okay, next one. All right, all of these down here, I see a power with a base of e, so there's really no question. I'm going to use natural log on everything, and a lot of these should be fairly simple. And that's natural log. Kind of looks scribbly, but okay, natural log of 200. So I natural log both sides of the equation. So this is going to cancel, leaving 4t. And again, there should be any shortcut here. We're taking natural log. Your work should look just almost exactly like mine. Okay, so that gives us 4t, and over here we have the natural log of 200. Nothing we can do with that one. And to get t by itself, we're going to divide both sides by 4. Do not divide by the 200 by 4. We're dividing the whole natural log of 200 by 4. So that cancels, and we leave t is natural log of 200 divided entirely by 4. Okay, let's put this in our calculator. Make sure you're getting the exact same answers as I am. Okay, put that in there, and I have 1.325. Okay, next one. Again, I see base e, so I'm going to natural log both sides of that. And these cancel here, leaving negative t. And then if this is negative t, I'm just going to multiply both sides by negative 1, and I have t is negative natural log of 0.04. And it's just a matter of popping that in the calculator exactly as it stands. And we should get something there. Let's see, negative natural log 0.04, close the parentheses, and 3.219. Looks like I got there. Okay, next one. This is similar to one that we did already, is that you have to have this power. You got to get this power by itself right here. So we have to get rid of this 1,000. So it's 1,000 times all of this. So we're going to divide. That's a little light. Divide both sides by 1,000. And these cancel, leaving e to the 0.09t is equal to 5. This is a base of e, so I'm going to take the natural log of both sides. And this side is 0.09t, natural log of 5, and then dividing both sides by 0.09. And this is the best exact answer I can get, and then let's go ahead and put that in the calculator. And I got 17.883. Okay, there we go.